Bismillahirrahmanirrahim. Assalamu Alaikum, ma'am. At the very beginning, I'd like to welcome you. Welcome to our presentation. Let's complete the introductory part first. I'm Nadim Khan Shanto, one of 4 group members of this presentation, bearing ID 191236225, a student of Textile Engineering Department, Daffodil International University. Today, we have chosen detailed idea about thermal properties as our presentation topic, and in this presentation we'll basically cover some topics like thermal conductivity, glass transition temperature, melting temperature, heat setting, heat of wetting, and finally flammability. So let's jump into the topic. Thermal properties. When a textile material is subjected to heat, it shows some specific behavior. The behavior shown by a textile material when subjected to heat is known as thermal properties. There are many thermal properties, and today I'll talk about one of the most important thermal properties, which is thermal conductivity. Thermal conductivity is an indicator of how easily heat can pass through a textile material. It refers to the rate of heat transfer in calorie through the body of a textile material by conduction. Thermal conductivity is correlated to the fabric comfortness. For example, the cotton fabric is highly conductive, and therefore it is comfortable to wear in summer season. In case of wool fabric, it is lower conductive as compared to cotton fabric. That's why it is comfortable to wear in the winter season. So from these two statements, it is very much clear that thermal conductivity is correlated to fabric comfortness. Thermal conductivity is affected by different factors. First of all, crystallinity. Highly crystalline polymers shows higher thermal conductivity. So, if the crystallinity is higher, the thermal conductivity will also be higher. The second factor is polymer density. Thermal conductivity increases with the increase in polymer density. So the higher the density, the higher thermal conductivity will be. Our third factor is polymer orientation. Polymer having highly oriented chain segment have higher thermal conductivity. Our fourth factor is cell size. The smaller cell size of formed polymer tends to lower thermal conductivity. That's why the higher cell size will be, the higher thermal conductivity will be shown. And finally, the temperature. Temperature decreases thermal conductivity of the crystalline polymers. We know the thermal conductivity increases with the increase in crystallinity. But if the temperature in crystallinity increases, at the time the thermal conductivity decreases. So these are the factors that affects the thermal conductivity of the textile materials. Finally, we'll learn some thermal conductivities of the commonly used polymers. The cotton has a thermal conductivity of 71, silk 50, wool 54, nylon 250, polyester 140, and finally cellulose acetate 230. So this is the part of my presentation. So now I'd like to call the next presenter to come here and describe his part of the presentation. Thank you so much, ma'am. Have a good day.
Assalamu Alaikum. My name is Michbahuzzaman Nowfel. My ID is 1912362. Glass transition temperature. Glass transition temperature is described as the temperature at which 30 to 50 carbon change starts to move. It refers a temperature up to which a textile material shows glassy state and beyond which it shows rubbery state. A glass transition temperature lies between 100 degrees Celsius to 300 degrees Celsius. Some factors influence glass transition temperature. One of them is homopolymers show higher glass transition temperature than copolymers. It is raised due to bulky side groups. It is decreased with an increase in chain bond flexibility. In some fibers, we show the glass transition temperatures. Like if we see polyester, the glass transition temperature is 69. Melting temperature. The temperature at which a textile material is melted completely and changed to viscous liquid, losing its identity, is called melting temperature. We denoted melting temperature at Tm. At melting temperature, textile materials start losing their strength and molecular weight. Some textile materials, cellulose and protein fibers, get decomposed before melting temperature. Some dependencies of melting temperatures. Melting temperature varies depending on fiber composition, how the fiber formed, and it depends on it. Polymer with larger scale has higher melting temperature. Rigid structure polymer also shows higher melting temperature. If the polymer is strong enough, the melting temperature will be higher. Presence of covalent and hydrogen bond in polymer structure increase melting temperature. Some differences between glass transition temperature and melting temperature. Glass transition temperature is a secondary transition. Melting temperature is the primary transition. Glass transition temperature has the ability to transform amorphous phase, or it applies on amorphous phase. Melting temperature applies on crystalline phase. Which fiber has a crystalline phase, the melting temperature will apply it. Glass transition temperature involves a change from solid state to rubbery state. Melting temperature involves in physical solid change to liquid state. That's all. Thank you so much.
Assalamu Alaikum, ma'am. Myself, Hasibur Rahman Sazib, ID 19123623. Now, I am talking about heat setting. Heat setting refers to a heat treatment which imparts elasticity, resiliency, crease resistance, shape, retention, etc. to a textile material. In other words, heat setting is defined as a thermal treatment applied to textile material in dry or wet state by the successive heating as cooling so as to impart elasticity, resiliency, crease resistance, shape, retention, etc. In case of man-made fiber, heat setting must be done to keep the dimension of the fabric duration. Further heat treatment, generally spandex, extension, etc. are heat set at 180 to 200 degrees Celsius based on different brands. After the heat setting is done, a material can retain its original dimension up to the setup treatment. The process is done by hot air or steam flow treatment. Heat setting is generally done before the melting temperature, whereas dyeing is done over glass transaction temperature. Also, heat setting of the fabric provides desired result during dyeing. Type of heat setting. Temporary heat setting. This is generally destroyed on by regular use of the material, such as steam-pressed cotton textile. Semi-permanent heat setting. This is applied to a material above its TG and given a specific form, such as hot washing above TG. Permanent heat setting. This type of finish lasts until the material is destroyed, such as heat setting to make new crystallites. Advantage of heat setting. It increases elasticity and resiliency. It impacts crease resistance. It removes scratches from the fiber. It also provides dimensional stability. It increases crystallinity. Disadvantage of heat setting. It bearing change to fiber color. It decreases dye take up percentage. It makes fiber very stiff. Thermal expansion. Thermal expansion refers to the frictional increase in length of a textile material due to the rise in temperature by 1 degree Celsius. It is generally measured by the coefficient of thermal expansion. Let the initial length of a textile material is L. The temperature has been increased to 1 degree Celsius more than it was before. Therefore, it's been increased del L in length. Now, thermal expansion will be increased length divided by initial length. Here, increased length is del L and initial length is L. So, we can say mathematical term thermal expansion is equal to del L by L. That's all of my presentation. Thank you, ma'am. Assalamu Alaikum.
Assalamu Alaikum, ma'am. My name is Mahinul Islam. My ID is 1912361. Heat of wetting. The amount of heat given off by a textile fiber due to the moisture absorption is called heat of wetting. In other words, when a textile material absorbs moisture, it gives some amount of heat. This given amount of heat is called heat of wetting. Let 1 gram of dried textile materials has completely been wetted. Here, heat in calorie per gram is involved, which is called heat of wetting. Heat of absorption, on the other hand, is something that results from the change in moisture regain rather than the thermal conductivity. Flammability. Flammability is defined as a measure of how easily a textile material can be burned in presence of heat or flame. The weight and wave of the fabric affects how easily a textile material will burn. Generally, untreated natural fibers, cotton, silk, etc. burn more quickly than wool. Factor influencing flammability. Flammability decreases with the increase in crystallinity. Flammability decreases with the increase in rigidity. Flammability increase with the increase in amorphousness. Flammability increases in presence of covalent and hydrogen bond. Flame retardancy. To prevent the excessive flammability of the textile material, flame retardant finish is applied. Generally, fabrics are treated with phosphorus and nitrogen containing chemicals so as to impart flame retardancy. Mainly, tetrahydrophosphonium chloride is used to attain flame retardancy. Phosphine, formaldehyde and hydrochloric acid, etc. are also used for this purpose. Thank you, ma'am. That's all of my presentation. Assalamu Alaikum.